Assalamu alaikum, my dear students. This is video number 510, and in this video, I'm going to discuss properties of inequality, properties of equality that we are using in various fields of social sciences, especially in economics. In modern mathematics, the relation equals can be used between any two mathematical objects of the same type, such as numbers, matrices, ordered pairs, sets, functions, etc. To say that A is equal to B is simply to say that the symbols A and B represent the very same object. Thus, the concept of equality belongs to mathematical logic rather than to any particular branch of mathematics. Equality always has the following fundamental properties no matter what kinds of the object it is applied to. In the following statements, A, B, and C can represent any mathematical objects whatsoever. However, in our applications, they will usually be real numbers. So, the various notations are the symbols that we will use in the following discussion will constitute real numbers. So, let us start with the general properties of equality. So the first property of equality is reflexivity, and reflexivity means that an object is equal to an object R, a real number A is equal to itself. Symmetry: if A is equal to B, then B is also equal to A. This is the property of symmetry. Transitivity means that if A is equal to B and B is equal to C, then A is equal to C. So transitivity means if A is equal to B and B is equal to C, then A is equal to C. Uh, then there is substitution property. If A is equal to B, then B may be substituted for A in any mathematical statement without affecting the statement's truth value. In addition, for real numbers, we have the following properties. The first five statements say roughly that if you start with a true equation between two real numbers, you can do the same thing to both sides and still have the true equation. The last two statements say that if you start with two true equations, you will still have a true equation after adding them together, multiply them together, subtracting one from another, or dividing one by the other, provided you are not dividing it by 0. All of these statements can be proved using only reflexivity of equality and substitution. In these statements, A, B, C, D represent arbitrary real numbers. So, if A is equal to B, then A plus B is equal to B plus C, and A times C is equal to B times C, and A minus C is equal to B minus C, and that could easily be proved. If A is equal to B and C is non-zero, then A divided by C is equal to B divided by C. If A is equal to B, then minus A is equal to minus B. If A is equal to B and A and B are both non-zero, then A raised to the power minus 1 is equal to B raised to the power minus 1, or the reciprocal of A is equal to the reciprocal of B. If A is equal to B, then A square is equal to B square. That is, we can take square of A and that must be equal to the square of B because A and B are equal to each other. If A is equal to B and C is equal to D, then A plus C is equal to B plus D, and AC is equal to B times D, then A minus C is equal to B minus D, and that can easily be proved. Number 7. If A is equal to B and C is equal to D, and C and D are both non-zero, then A divided by C is equal to B divided by D. Thanks for watching this video. I hope this was informative and useful for you. If you haven't yet subscribed to the channel, kindly do subscribe, and don't forget to click on the bell icon so that you can get timely notification about my other videos that I'll upload for you. Thanks for watching. Kindly subscribe. Kindly share various videos of this channel with various students, colleagues, and